In the next slides, we'll summarize all the important topics that we're going to cover throughout the course. So this diagram here is actually quite crucial. Many of them may not make sense to you. That's why you're taking this course. But some of them you have seen them already, but you do deserve some review on these topics. Let me go over that very, very quickly with you. Just to point out, later on, you should always come back to this particular diagram over here to see which topics you have learned and where you should put them in the context. So let's talk about something you know already. We talk about object-oriented programming at this box over here, which you learned from 1022, 1021, 2030, and 2011. So you learn about how you can do code reuse using inheritance and also the substitutability principle. Okay, so these are the two things we have to review because we're going to talk about design patterns throughout the course as well. So we do need all the principles for this inheritance and substitutability, especially polymorphism, what does it really mean, and also how you can have a polymorphic collection. And we got typecasting as well, and also we got static typing and also dynamic binding. And also we talk about unit testing. So these are the things you learned previously already, but we are going to review to make sure we can put them in the good context of software design. And also you learned about logic. So this is back in your 1090 class. So you learn about axioms, lemmas, theorems, and also learn about predicates, propositions, and equational proofs. That's something we're going to need at the end of the course when we learn about program correctness. So also proof by contradiction by finding some witness. So these are the things we're also going to need later in the course. And we talk about IFO. So IFO is actually the language which I will justify by the end of this particular lecture, why we are choosing it to teach design rather than using the language that you're familiar with, which is Java. Okay, so there will be certain syntax you have to learn for IFO. That's why we're gonna give you some tutorial videos and give you labs to complete, so you can get used to the syntax. So there will be syntax for implementation, and also there will be syntax for specification. So this is specific to design, which is new to you. And also we're going to learn about agents for functional programming. We'll see that later when we talk about event-driven design. And also we're going to use the cross constructs. So this is a special syntax that's very unique in IFO, but it's actually unique but very useful. So it's actually for you to actually express logical quantification in your specification, either universal quantification for all or existential quantification there exists. So cross is actually very useful. We'll see that very soon. And also how we can do, remember back in 2030 you learned about aggregation versus composition. So to really do composition, we actually don't have to manually do the copy constructor ourselves like what we did in Java. But now in IFO, they have a way to support composition very conveniently using expanded type. We'll see them as well. And also, there's a way for you to really do encapsulation using export status. We'll see that as well later. And we briefly mentioned that we're going to see exactly what runtime contract checking is at the end of the lecture. And we're going to use debugging for IFO. So IFO has a tool called IFO Studio. In IFO Studio, they like a normal programming IDE. They also support breakpoints and debugger. So that's why I'm listing that here. That's also a very important concept for your software developments. Okay, and also design over here. So the design will be language independence. So we're going to learn about abstract data types. You learned, I think you maybe encountered this concept in 2011, but I'm going to review that possibly in a more specification-oriented way. And also cohesion is a very nice principle for design. And also single choice principle to avoid duplicates. Open close principle to really make sure your system is both open and closed at the same time. It sounds contradictory, but it's actually not. We'll get there when we get there. And also design documents. So for one of your later labs and also your projects, specifically the projects, you will have to write a design document yourself, because design is not just about programming. It should be also about communicating your design rationale or design decisions. Especially you can see justified design decision. Usually you have to There'll be design decision. There'll be one point you have to mention in the report, in the project design documents, and also for the architecture of your modules or your classes. So these are the just two examples items you have to include in the design documents. We'll give you some template, and also we'll give you tutorial on how you can use how you can write design document. That'll be a very valuable experience for you as a software developer. Okay, so we talk about the 4 squares over here individually. Let's now talk about their overlaps, which will give us some more idea. That's also very critical. Let's simply see the overlap between OOP and also design. Okay, so we talk about architecture. So there will be 2 possible architectural relations that we have to design. So remember, I told you that you will be given the freedom to design the classes and the methods. So now, to really design your classes, you have to think, well, all the classes don't just exist in isolation, do they? So they have to be somehow related. But how can they be related? It could be either client supplier, okay, or it could be inheritance. So both of these will be seen very soon, possibly after lecture 1 or lecture 2. And there's a very nice design principle called programming to the interface, not to implementation. So this has something to do with the polymorphism. So we get to this principle later. We'll actually see some concrete example. And then we talk about a very important principle here called modularity. So we'll see daily examples for modularity. It's actually something not just specific to computer science or software design. It's actually some daily principle you have been applying throughout your life. And we talk about design patterns. So design patterns are simply recurring solutions to the common problems that you might encounter into either in your job interview or in your workspace. So now we'll talk about a number of design patterns, but this list will be by no means exhaustive. So I would suggest some reference book for those of you who might be interested in learning more patterns. You can read a book for your self-study. But we're going to see iterator, singleton, state pattern, template pattern, composite, visitor, strategy, observer, event-driven design, and also anti-patterns over here simply means what's the no-no. So when we talk about patterns are the good practice for you to apply. And also throughout the course, I will also tell you whenever we see some poor alternative solutions before we talk about the ultimate solution. So these are more like the anti-patterns because they have flaws and also they got limitations. We want to avoid them. Okay, let's see the overlap between the design and also the iPhone. Okay, so we'll see design by contracts very soon in part 2 of the lecture, and also we'll see you can see class invariants, pre and post conditions, right? I just briefly mentioned them, but we'll see in details later. And this will be one of the most important principles we have to see, information hiding principle. And the information hiding principle is actually supported very well by the IFO syntax. So that's why you shouldn't really see IFO as an obsolete language. It's actually a good language for teaching you the ideas about design. Information hiding just one of them. And there will be one particular framework called the IFO testing framework because we're using IFO in this particular course. So when you do the programming or design projects or labs, they have to be in IFO unavoidably. But the ETF, starting from your lab number 3 after the reading week, we actually use this particular framework. So it's actually the gold for this particular course because by programming in this particular ETF framework, you will be given complete freedom about coming up with the names and also signature of your methods, and think about what classes you want to have in your projects, and also what should be the relationship between them, either client supplier or inheritance. So that's really something you haven't done before. Remember in 2011, in 2030, or even in the previous courses, you're always given the API. But now, by using ETF, you will be responsible for coming up with your API. So that's really a unavoidable task you have to perform as a software developer. So we'll let you practice that in this course. And then we'll talk about abstraction. Abstraction is simply just a way to really filter out all the irrelevant and low-level details. Especially, rather than thinking about hash tables, you can think about mathematical relations. Rather than thinking about arrays, you can think about mathematical functions or sequence. That's something we have to show you. You always have to you can always think in terms of the code level, but that's actually too low. And if you actually think in terms of code level, you can easily get lost, especially for the big picture. So you want to promote your thinking to mathematical objects. Basically, everything you learned back in 1090, sets, relations, functions, and also propositions, predicates. So these are the mathematical abstraction you want to have about your software. You might be a little bit wondering, oh, how can I link between math and also code or design? We'll show you. That's one of the important learning outcomes for this course. And then we talk about regression testing. Some of you might have experienced this already. Regression testing simply means you got to run over your test over and over again. Every time you introduce any change to your programming project, you have to rerun all the test cases to make sure everything still works. So when you do your reading for study, we said regression is not very good because you don't really want to read the same paragraph over and over again. But in the case of software development, regression testing is actually a must practice. It's a good practice actually, because every time you introduce any change, introduction, any new functionality, or do any fix of your code, you must make sure whatever test cases that passed before, they still pass right now after the change. Okay, we'll see regression testing very soon. And also acceptance testing, I briefly talk about the acceptance by your customer over here because it's actually free of implementation detail. So there will be one kind of testing technique called acceptance testing. So we'll see this when we talk about ETF. So that's also one of the reasons why using ETF is a very good way of train your design mindset. And also voice safety. So this is actually a very strong checks by the IFO compiler, and I will actually contrast when I get to the voice safety lecture. In Java, if your code compiles and you execute your code, there's no guarantee that you wouldn't run into null pointer exception, right? Actually, the opposite. You always run into null pointer exception, even if you are a very experienced programmer. It's just unavoidable. However, voice safety in the context of this course goes like this. Every time when you actually try to compile your projects or code in IFO, if the compiler says, if the compiler is happy and compile your code, it's guaranteed the type system makes sure the code executed at the runtime will never run into null pointer exception. About how, that's something we'll see. And also we talk about generics. Generics is somehow related to the inheritance over here. That's something we'll also talk about. We'll first talk about how you can use generics, first of all, and then we talk about what's really the theory, well, a little bit of theory and also rationale behind using generics rather than otherwise. And also we'll see something like a multiple inheritance. So now, for a single class, it might be that you have more than one parents. And notice that this is forbidden in Java. However, for design purpose, multiple inheritance having more than one parent classes is actually desirable design property you may want to have. Okay, also we talk about subcontracting. Subcontracting simply means when you actually talk about design by contracts. But what if you want to put design by contracts together with inheritance? When these two orthogonal items play together. So that's actually what subcontracting is about. What does design by contract really mean in the context of inheritance? Okay, finally, you will be asked to understand and also to draw architectural design diagram, right? Remember for the design documents over here, I said you should really learn about architecture. So architectural diagram. There will be some specific notation you have to know, which is very intuitive. We will have one lecture about how you can draw design diagram. And also later on, you have 1 or 2 labs, and also the project you have to draw design diagram to practice. It's actually very nice practice for you to keep in your skill set. Okay, finally, let's talk about the intersection between IFO and also logic. Okay, so there will be some specification syntax you have to learn to really do contracts, especially you can do Boolean predicates. For example, in 1090, you have this particular symbol for logical implication, and there is no direct correspondence in Java, correct? But in IFO, you can simply use implies. So that's a keyword you can use when necessary. That's something we'll see later as well. And also for the loops, which is actually very easy to get wrong. You might run into infinite loops that never terminates, or you may simply get a loop that got a one-off error, or it simply doesn't produce the expected result. So we have to use the contract for the loops in order to make sure your loops is actually producing the correct result, and also it terminates. So we had to use invariants and variants. So towards the end of the course, we also talk about contract for the loop. And once we get contracts for your methods and also for all your loops and for your class, we can then talk about what does it really mean for your program to be correct in a formal sense. So we'll talk about two things, a little bit more theoretical. So these two topics will come at the end of the course. We'll talk about weakest precondition, and we'll talk about Hoare triples. Don't worry about these two terms. Of course, they wouldn't make sense to you for now, but I just want to mention, I want to somehow give you some overall picture about how everything eventually will connect together. Okay, so we'll learn about weakest precondition. We'll learn about Hoare triples in order to prove formally that your program is correct. And also, we'll talk about specification using higher order functions, and especially using agents when we talk about event-driven design, which is also possible in other languages. For example, if you program in C#, they actually got delegates. If you program in Java, they also got lambda calculus. However, the way agent works is actually much more intuitive, hence more suitable for design in IFO. Okay, again, this is just a very quick overview of all the topics that we're going to cover in this course. I'm going to upload a clean version of this diagram on the lectures website, and keep this diagram handy. Every time if you learn about a new thing from the lecture, you should really go back to this diagram here and see where the item fits into the overall context. So now let's give a clearer definition about what a design is. In order to do that, I would like to go back to the iPad notes over here, and then let me highlight the components that are needed for the definition. So number one, we need to know about architecture. So here, when we talk about architecture, it's going to be either client-supplier versus inheritance. And by the way, client-supplier is very similar to what you learned as aggregation in your 2030, the object-oriented programming course. And the first dimension will be architecture for design, and then the second dimension will be specification. And for that, in order to really write well-documented and also unambiguous and also precise specification, we have to use design by contract. We're going to write precondition, postcondition, class invariants. So these are the two dimensions for defining design. So let's go over just one more slide before we talk about special terminology for the design. Okay, what the course is about, of course, design. So the focus for this course, of course, will be design, even though we're using a new language called IFO, but the core ideas is really language independent. It's just that IFO is a more convenient language for the concept to be taught and also for you to learn. That's really the reason why we choose a new language. So architecture, as I said before, is going to be interrelated modules. The relationship between classes or modules can either be client-supplier or aggregation, or it can be inheritance, either one of them. You have to make a decision as a designer which one or a mix of them should be the case. And the second dimension for the design will be specification. So we want to have precise, functional. So functional, you can think about basically whenever you want to write precise specification, you're basically writing a predicates. So predicate is what you learn in 1090. Or in a more programming sense, you can think about predicates is a Boolean expression. It's going to be either true or false. So precise interface of each module. So we'll see exactly how to do architecture and specification throughout the course. But for now, if you want to know concise definition for design, think about it as two dimensions. A design will consist of, number one, architecture for interrelated modules, and number 2, for precise specification of the interface, meaning that for every method in your class, they should be well documented. And the API, the Java doc that you learned in the previous course will turn out to be not sufficient. Okay, we'll argue that later. And for this course, the main idea will be really about design. So whatever implementation you have to supply for your labs and the projects, efficiency may not be as much as a concern as in the previous courses. Like in your 3101, if you're taking it, or in your 2011, where you have to justify for a particular data structure to satisfy certain asymptotic running time. But it's not the case for this course unless otherwise specified. But I would say in general, you can assume if efficient implementation is not really the criteria for the soundness of your design. So you can imagine that once you get a design that's actually both feasible and also correct, we'll talk about feasibility and correctness later. Once you get a design that's both feasible and correct, there will be some so-called refinement process, which means you can turn your design. For example, if you try to design your system in terms of, remember we talk about abstraction. If you design your system in terms of a mathematical relation, so that's abstractly speaking is actually a very mathematical idea, but I can later on refine that into efficient maybe hash table. Okay, but for this course, it's really about promoting your thinking above the code level. That's really important thing to note. Okay, so always remember this principle here. So now, having a suitable language for teaching and learning design really matters the most. Java turns out to be a very suitable implementation language when you get to this particular refinement process. However, before that, if you really want to catch the defects in the design phase, Java turns out not to be the right level of abstraction for the language that you want to use. We'll argue that later. We'll give you a concrete example to explain to you why it is the case. Okay, so the question is Java also a good design language? While Java is a good implementation language, we are not denying that. However, is Java really a good design language? Okay, in order to answer this question over here, we have to understand what a good design is. So now, starting from the next slides, we'll start talking about some important terminology about contracts, client, supplier, and also design by contracts.